2, 1.
Hello, everyone. I apologize for that short delay. We had some things we had to reshuffle around. Appreciate everyone for joining us. Today we're going to give you a short presentation on troubleshooting for heat trace, electrical heat tracing with Chromalox. With us today is Chad Gautreau. He is a regional technical sales manager for Chromalox. He has 40 years experience in the power distribution world. 20 of that is with heat trace. So he's going to review some applications and give you some basic troubleshooting tips when you're assessing your heat trace install. Now, before we get to Chad, I did want to take this maybe an opportunity for some of you just to give you a quick say introduction, refresher to some of the products that Chromalox does offer in the heat trace world. You know, you can always go to our website. Please advance. Sorry, we're having a issue here. Marissa, can you go to the, there we go. Perfect. So, you know, we have all the literature, the install guides, a lot of design guides, testing and all that stuff. And we'll actually show you some where you can find YouTube videos to go through and test your install. And like I mentioned, before we get to Chad's presentation on basic troubleshooting, I just wanted to maybe walk through it and highlight some of the products and value that our heat trace line does offer, and give you a quick 2-minute tour of the factory. So stay tuned for that. So to start with, we, as you know, all heat trace manufacturers, we have what we call our SRL line. Next slide. Our SRL line, which you know, this is your typical freeze protection, you know, standard low temperature stuff. From there, we have what we call our SRP line. P is for process. This is for your higher temperature process lines, maintenance lines, maybe chemical facilities and stuff, up to about 230 degrees F. If anything goes beyond that, we have our SRME line of products. That's good up to 425 temperature. So you think of like your oil and gas applications, your chemical plants, and you know, these are all products that are stocked on our shelves that we'll show you here in a second. From there, I would like to just highlight our connection kits. A big part of heat trace, not only is the install and layout, is, you know, how this all comes together. And we have, you know, just a great line of universal connection kits, universal in the fact that we have, you know, global certifications, and they're a little unique on how they come together. We're all fairly familiar with this type of connection kit, but if you notice on the next slide, we have a grommet connector. So basically that grommet gets sandwiched with the heat tracing. It negates the need to have you know, teeth in the standoff. You don't have weep holes for water ingress or any of that stuff. It seals the product and allows for accessibility and ease of installation. So I always like to point that out to everyone when you're using the Chromalox line of connection kits. Now, just really quick, just for everyone's, you know, information, we of course have the Class 1 Div 1 line of heat tracing products. We simply have a designation of H in front of it. It comes with its own set of connection kits that everyone should be familiar with, and that's the, you know, the standard you know, hazardous Class 1 Div 1 connections cast product line. From there, we do have constant wattage line of products. That's for all your direct burials, your freezer floors, your frost heave applications, and we have design guides for designing each and every one of those applications available on our website as well. There is a long line product that we have available, and certainly wanted to point that out to everyone. If you want to know about any of these in depth, you're going to be welcome to contact me or Chad or even Charlie from previous presentation to help you design this. Again, the design guides are online. A couple more quick things before we get to the tour. We have a unique product known as our DTS product line. Of course, we have MI cable as well. Apologize, got ahead of myself. So we certainly have a full line of MI cable. Getting to this DTS, this unit is kind of unique to Chromalox. You actually have a numeric temperature indication on the front of the box. It is Class 1 Div 2 for all your installation areas, and it comes with a 30 amp SCR solid state relay integral to the unit. So it's your power connection kit, it's your sensor, and your single line controller all in one box. What that does and provides to you is that is an integral soft start. So it basically will pulse on your cable. There's no programming, there's no anything else you need to do besides set it and forget it. But this will allow you to have longer runs of cable and eliminate the concern of a tripping on cold starts. Like I said, it has a pulse mechanism in there that acts as a integral soft start with that. From there, we obviously build up from there. We have a universal design to our control panels. We have the single and dual loop controllers. These are on the shelf, and we'll show you here in a second. You can have these tomorrow if you need them. In that case, there's a nice HMI that is universal on all of this power or panel controllers. That you have your set point, your maintenance temperature, but you also have the ability to have current monitoring integral to the unit. It's just an add-on that comes with it. If you need more than 1 or 2 runs, that's when you get into our larger panels, which would be our ITLS, ITAS. AS is for ambient sensing, LS is for line sensing. It's just important to remember that these come in 6 circuit buckets, right? So you can get up to 72 loops or circuits in one panel. And then we have extension panels to go with that. But the HMI display is exactly, mirrors the smaller one, and it has all your controls. They're easy mapping sensors, and it's just a great product that makes your design, your install, your takeoff, your project, it becomes very easy to do with our design guides and everything available. And then of course we can, either go more advanced or less advanced. We've got just simple weather trace panels for just switching on and off lots of circuits when you don't want a lot of feedback, or we can offer supervisory controls. Again, just a quick overview of the products that we do have available, and we invite any of you to contact us if you want to get in depth on any of these. As of course, we just wanted to run through this before we get to the troubleshooting portion of this with Chad. Now, before we do, I wanted to just take the opportunity. Obviously, we can't get everyone to the plants, the factories, tours. I would like to at least open the doors and show you our facility, so you can have an idea of what Chromalox has and what we have to offer. And with that, I'm going to kick that over to that. And here's essentially our facility in Laverne, Tennessee. This is where we manufacture all our heat trace products. This is where we house all the connection kits, and you can basically get same-day shipping for any of your orders. Now, this facility is a 150,000 square foot facility. It's state-of-the-art. It's brand new. There's also a controls division that's housed there for our industrial products. So we can get as elaborate with a design or as simple. And the good thing is, a lot of your heat trace specific projects, we have the stuff on the shelf. As you're going down our heat trace hallway here in our stock check, you can see the SRME product on the right, or SRL on the left. That SRP was down on the end. Here's the manufacturing facility for our heat tracing. You've got the core extrusion. You've obviously got the palleting of the product there. This is where the grounding mesh gets put onto our wire, and that's actually something very unique in Chromalox. You'll notice with many manufacturers, the grounding mesh on your heat trace cable. Some of the lesser manufacturers, it's very loose. Ours is extremely tight, so it is good safety, good adhesion. You're all set. Again, going back down our heat trace hallway here, you had the SRP product there, the medium temperature stuff on the left, the SRL on the right. We at most times have just miles of this stuff ready to ship and available. So if supply, design and all of that is a concern, we certainly have available for all of you. Just wanted to give that quick walk through our factory, just to visualize and show what Chromalox has to offer. Obviously, our loading docks on the back. We have a full testing lab. I think it's important to point out, you can kind of see it in the back without getting too detailed, but each pallet, each roll of cable that you see there are actually checks along the way, and that stuff is all tested. So we can actually go back 10 years to product we've manufactured and show you what it left the factory as. So certainly another safety offering that we have to you. So I know that was just quick in general, but thought it would take the opportunity to show everyone that. And now we'll get on to the heat trace troubleshooting portion of the presentation. Thank you. Chad, I believe you're up.
Oops. Okay. Bear with me for just a second here. I think I started this from the beginning and I don't want to do that. Let me get to the right screen here. Sorry about that, guys. Okay. So just a little brief history of Chromolux. Most of you probably or may not know, Chromolux has been around for 100 years. We granted our first patent in 1915. So it's quite an accomplishment for a company that been around for that long, and we have the full breadth of electric products, heat tracing products and applications. We're still headquartered in Pennsylvania, Pittsburgh, Pennsylvania. Derek spoke about our manufacturing facility in Laverne, Tennessee, and of course that's where we make all of our cable, panels, controls. Our application engineering is there, our design engineering, the warehouse, and our site service where we do all of our service work. It's also located out of Laverne, Tennessee. That is a suburb of Nashville. That's about 20 miles south of Nashville. So what I want to do this morning is kind of give you guys a brief overview of troubleshooting heat tracing, and we're not going to dive into the details of taking actual tests and equipment. We'll show you some of the places where you can go do that. But what I want to do is give you some things to look for and things that you can go out in the field and visually inspect and kind of test. But before we do that, I want to just kind of briefly talk about heat tracing design categories. To me, there's three different design categories. There's what we call freeze protection, and freeze protection is the prevention of water from freezing in pipes and vessels. And that's typically controlled by an ambient sensing thermostat and as a group controlled application. Most people are probably aware at that point I'm turning on a number of circuits with a contactor when I get below a certain temperature or when I get to a certain temperature, and then when I get above a certain temperature I turn those off. So that's what we typically refer to as freeze protection. We're typically dealing with water. Process maintain, on the other hand, is the maintenance of a specific temperature based upon process chemical data, and that's typically a single sense lined RTD and a single controlled circuit application. A little different from water in that we need to make sure that we don't overheat that temperature. We're looking to heat that during at a specific flow path, and so it's a little different from freeze protection. And then thirdly, we got what we call commercial applications. That's where we're doing snow melting, gutter de-icing, hot water maintenance, those type of applications. What is heat tracing? Most of you may or may not be aware, but heat tracing is used to maintain the temperature in a non-flowing condition. So we basically need to understand that we can't heat up a line or a vessel unless it's non-flowing. So if we look at a line that has just no heat tracing on it, just insulation, you'll see that over time it's going to seek some temperature, it's going to get to some equilibrium, it's going to seek down to that level, and it's going to stay there. What we need to do is put back that heat loss, and that's what heat tracing does, right? It's going to give us back that heat loss that we need, and then we're going to maintain the temperature that we're looking for over a specific period of time and be able to stay at that temperature. And that heat loss comes from your basic thermodynamics equation, right? Heat loss equals area times the temperature difference divided by thermal resistance, which in this case is our pipe size, minus the fluid temperature, fluid temperature minus ambient divided by our insulation types and thicknesses. That equation comes out of our calculation, chromotrace calculations. So those are done automatically today. Years ago, you had to go into the graphs and calculate those types of heat losses. So that's a basic overview of heat tracing. So just want to make sure everyone understands that. So let's look at 4 key categories or systems that you need to look at whenever you're going to do some troubleshooting and heat tracing. And those all fall into insulation, heat tracing, cable and components, our electrical power distribution system, and then process, any kind of process considerations that we need to be aware of. If we look at a typical heat tracing system that's uninsulated, if you take a look at some of these pictures, you can see that around valves, around pipe shoes, flanges, we have extra cable, and that's to account for those heat losses that we have in those specific areas. So we need to make sure that whenever the heat tracing is put on, that those cables, those areas are heat traced properly. Once we're insulated, we can't see that. We don't know where that's at. So know that if you're looking on top of the insulation, then you know that hopefully that those areas have been heat traced correctly. So one of the things that I like to do if we're going to do heat tracing is do some testing or troubleshooting on heat tracing is to start with a basic heat tracing isometric. If you have that isometric is going to give us maintained temperature. It'll give us the pipe length. It'll give us the circuit length of the heat tracing. It'll tell us what our startup amps are, what our steady state amps are. So it's just a great starting point for going out and troubleshooting. So if we're looking at insulation, the best thing to do is to take that isometric and walk the line and note any kind of damaged insulation, any kind of missing insulation we may have. Do we have any insulation blankets? Are they properly installed? Do we have insulation blankets that are missing? Many a times I've been to a site to go look at a trouble area and the insulation blankets are sitting there laying on the ground. So that's not going to help us if they're laying on the ground. So make sure those things are on, they're tight, they're properly installed. Does the circuit have the proper type of insulation and thickness? Make sure you caulk and reseal around components. A lot of times clients will go back and do work on heat tracing. They'll strip off a section of a line and they just may go back and put back on whatever insulation they have instead of trying to follow the guides that are on the heat tracing isometric. The problem with that is that insulations have different types of heat loss. So you need to be careful going back if you do work and try to go back and put back on the proper insulation and thickness that's in the design. If we look at insulation, clean insulations, projects have been installed, you can see the jacket in here is nice and clean and smooth. I'm caulked around the power boxes and my end seals. They're caulked up really nice and neat. But when you really go walk down a job, this is what we kind of see. We see busted corners on the insulation. If you look off over to the right up there next to the gentleman, you'll see there's insulation blankets that are missing on that valve. Another thing here that I'll mention is it appears he probably has a steam hose and he's shooting steam up underneath insulation to try to thaw it out if it's cold. That can cause a lot of issues. Any place we have insulation that's damaged, as what you see in this picture, is water is going to ingress into there. You're going to get a cold spot that's not going to be able to maintain the temperature, or we're going to have heat loss that's going to come out of there. Same thing on the top, you see a valve's missing here. I mean, a blanket's missing on this valve. If you're going to cut and cope, you got to make sure that you go back and do it properly and seal it up. In this case, water can still get in here. We can get the ingress of water. This is not properly sealed off. This could be an issue for us whenever it gets really, really cold. And of course, heat tracing does require insulation. You typically just are not going to be able to get to your set point unless you insulate a line. Someone asked me before, well, can't I just put the heat tracing on? I don't need insulation. And I kind of liken that to telling them if it's 32 degrees outside and you turn the heater on in your house and take the roof off of your house, you're not going to be able to maintain a comfortable temperature. Same thing applies for heat tracing. It has to be insulated. There's no getting around that. So just keep in mind, insulation is a big part of a heat tracing system. And the majority of the time when we go to look at a troubled installation, it's 90% of the time we find issues with insulation. So make sure you go back and get the insulation back intact like it really needs to be. So let's talk about the heat tracing side of troubleshooting. Again, I like to start with that isometric, right? Let's look at that. Is the heat tracing circuit drawing the current that it's supposed to? Do I have a lighted end seal that I can look and see that I have continuity through the line? If the heat tracing circuit's drawing current, you may have a controller that gives you that information. If not, you may have to go with a meter and try to do some tests to see if the current, if you do have the proper current. Is the system coming up to the design maintenance temperature? Look at that and see, is the RTD mounted and wired correctly? I've been to many projects where someone's gone back and done some work and the RTD's out there hanging in open air. And so it's sensing ambient temperature instead of line temperature, and it's not, the system's not operating properly. Are my controls set up properly? Did someone go in and change the set points or what we had originally on the original design? You can force the heat tracing circuits on. If you have a switch panel that's mounted HOA, you can force that into hand mode. Some heat tracing controllers have an auto cycle program. So you can do that in early summer and figure out that your heat tracing is working. Or if you're in the emergency mode, you can switch this thing to hand and turn everything on and then go do some checking. I talked about steam hoses used for thaw out. One of the issues with that is that you will damage the conductive core of the heat tracing cable if you put too much steam on the wrong cable. So make sure you understand that. That happens a lot, and a lot of times the conductive cores get destroyed, and then that section of the heat tracing is not working, and we end up with another issue in terms of heat tracing. This is a recent installation of a photo we just got, which is kind of says it all. Someone tried to take the heat tracing and install it on the outside of the insulation. Obviously, this is not going to work. So we need to make sure that the heat tracing is under the insulation. It's just kind of unbelievable what some people will do, but this obviously is not going to work. So make sure that you stick it underneath the insulation. Let's talk about electrical. So all of my electrical wires for power and RTD. You know, one of the things we can do is we can go to the power box, we can measure the heat tracing cable and make sure that it's making properly. We can check for proper operating current levels. A lot of times what you'll find if you have a ground fault, a couple of things could be happening here. We have water in the power box, or someone has a cut, or there's a screw or a nick in the heat tracing cable. A lot of times that comes from maintenance work that's been done. We stripped off the insulation, we redid some piping, we put some insulation back on, and the insulator shot a screw into the heat tracing. So now we got a ground fault situation there. So another reason why you may have a breaker tripping is we've taken an existing circuit, we've added on some heat tracing to that, and now we're exceeding what the circuit breaker is capable of handling. So make sure, that's why I like to take those ISOs and update your circuits and make sure that someone just doesn't go and add something on, and now I've got a case where I'm drawing too much current on startup, or I'm drawing too much current on steady state and my breaker's tripping all the time. One of the things that I like to tell people, the best place to start is where's the last time or the last section of heat tracing circuit that required some maintenance. Typically, if we're going to have an issue, that's the best place to start. That's the last place we redid something. That's going to be typically where we might find some kind of issues. So you can also test your power and RTD wiring if you get to the point to where we've eliminated the other issues in on the electrical side. Maybe we have some issues with the power that's ran to the power box or the RTD wiring, so we can do a test on those. Some of the issues we find with electrical also are broken power boxes. Someone will hit a power box. If you look over here to the left and you see that power box is angled or it's leaning, so the cables may have come loose in the terminations. So look for these types of issues also. You may want to, you may want to take a look at that. One good thing to look at this picture also, as you can see, is someone coped out the insulation to put that power box in, where we're going to get water that's going to go down where that power box is. That's not a good way of doing that. That thing needs to be sitting up on top of the insulation jacketing. Another issue sometimes we find is that the RTD is in shade. So this is an ambient sensing RTD that's turning on a freeze protection application. It's sitting in the shade. It's not sitting in the sun. That's going to give us some operations that are not going to be not what we're looking for. So make sure we put that out in the sun. We get that RTD where it's not sitting in shade. We want it to be able to detect the proper ambient temperature. The other thing I like to talk about is process considerations. So I kind of talked about the basics of heat tracing so that you would understand that we talk about flow and non-flowing conditions, and that heat trace is only going to operate when we have a non-flowing condition. It's only going to be able to put heat back in the pipe in that situation. So have an understanding of what the process is and how it operates. When do I have a flow in a non-flowing condition? Some people will say, hey, my heat tracing is not coming up to temperature, but in that particular instance, that segment of the process is in a flow condition. So the heat trace is not going to be able to bring that up to the temperature that you're looking for. Or are we attempting to heat up vapors, gases, or minimize condensation? Heat tracing is used for that a lot. A lot of times we see that in hoppers. And so if we have a lot of airflow through there, we may be taking care of the condensation or heating up the vapors and gases, but we're not actually getting quite up to that temperature. So kind of keep those in mind whenever you're thinking about trying to troubleshoot, and you may want to get your process guys involved so that everyone's on the same page. This is kind of just a quick install guide. It just is kind of, I'm showing this more or less for purposes of, we have a power box, we can get to a T, we have end seals. So it kind of gives you how heat traces or how heat tracing is laid out. Talking about end seals, one of the things I didn't mention on the other side is that if we have an end seal that's underneath the insulation and I don't have any isometric drawings, I don't know where the circuit starts and stops. And I'm relying on maybe a gentleman or a lady that's been working at the plant for a number of years, and this person knows all of the heat tracing, where it all starts and stops. Well, if that person retires or moves on, we have no idea of where the heat tracing starts and stops. How do we go about troubleshooting it? So that's why, to me, it's important to get those isometrics and have those isometrics, even if it's for 1 or 2 circuits, to go back and be able to troubleshoot and add. It just makes it so much easier whenever you're trying to go back and do some basic troubleshooting. I will mention we do have a field service department. It's fully staffed. We will do project startups, troubleshooting, programming, heat tracing audits. We'll come in and do a much more extensive audit of just your entire system and where your issues may or may not be. What I'm trying to do here is just give you some basic information for troubleshooting. So keep that in mind. If you have larger issues and you'd like for us to get involved, we'd be more than happy to help you come in, reprogram your controllers, troubleshoot, perform an audit. We can generate ISOs for you if we have to. Those kind of things are all rolled up underneath our field service. One of the things we get asked a lot about is, what do I need to provide if I need to do a heat tracing design? So this is, some of you may or may not be familiar with this, but this is the typical things we're looking for. We want the specifications of the heat trace, the electrical, and the insulation. So I covered those as the categories, as well as the P&IDs. The P&IDs are going to give me flow and non-flowing conditions, and that's how we're going to circuit something if we're going to do a maintain temperature, process maintain temperature application. Piping isometrics, area classifications, minimum ambient, maximum cable exposure, maintain temperature, insulation types and thicknesses, and is it a freeze protection or a process maintain? And also operating voltage. What operating voltage does the plant have? What operating voltage would they like for us to use? And one other thing I like to mention is the degradation of temperatures of specific products. So sometimes when we go and do a heat tracing project, we run into issues where certain products cannot go over a certain temperature. So if you do have those cases, it's best to let us know that up front so that we don't degrade product by overheating it, or we can shut it down before it gets to those temperatures. Those are the kind of things that we need to know and we need to look at up front whenever we're doing a heat tracing design. If you want to take a deeper dive into doing some actual test, installation, mega testing, we have a number of YouTube videos that you can go to and you can research yourself on how to prep the wire, how do I do a mega test, how can I check for stabilization of current. These are things that we perform through our service group. But if you want to take on those tasks yourself, we have a full line of heat tracing videos that are available to you. So I would encourage you to take advantage of them if you need to take, like I said, a deeper dive into doing testing yourself. And other than that, I guess we're going to check and see, Derek, if we have any questions that we need to address.
Yes, Chad, thank you. That was a good presentation. Quick overview on basic heat trace troubleshooting. A couple questions for you, Chad. The first question came with back, well, I guess in reference to the factory video with the reels of cable. You know, what is our standard length on the reels of cable? And that's at least pictured as 250, 500, and 1,000 feet reels. However, we do it's important to point out we manufacture in a much larger length in a single run. But then the issue of installation and shipping and you know, actually installing it around a pipe, right, lugging it around. So that's why those are the standard reel lengths. But we can always inquire about availability of other lengths if needed. Another question, and I think you just addressed it, Chad, was the is there a procedure to measure the cable, or documents or manuals? And I think you were just discussing that there in the YouTube.
Yep, we can go to, you can go to that YouTube video and it'll show you the procedure for measuring the cable and testing the cables. It'll give you a step-by-step process to do that.
Okay. And this next question, it's a good question, and maybe the photo we showed didn't illustrate what was maybe going on there. Would it not be better to put the RTD in the shade, so it is reading the worst case scenario, especially if some heat trace piping is in shaded areas?
No, because what we're trying to do is we're trying to sense ambient temperature, and if the RTD is in the shade and the weather is, it's really, if it's cold outside, then we're not going to get the proper. We want it to be exposed to the sun so that we know what the true ambient is. And so even though we have piping that's in shade, it's heat traced, it's insulated, so that's not really going to affect once the heat tracing's turned on.
Okay. I also commented too. I know from the picture, because I actually took it. That RTD specifically you had in your example was a line sensing RTD that they had mounted as an ambient sensing. So
that's right.
Was a complete other issue to discuss, right? Make sure you're installing the right product in the right place. Next question. When do you use controlled with limiter or without limiter design, and how does it work? I would imagine that would be output limiting.
I guess that's what they're speaking about. Control limit design.
Yeah.
We would typically we get
limiter or non-limiter design.
Yeah. Typically, we're going to get into control limit design when we start getting into using MI cables. It's really going to depend upon the application and what the typical application would be before we go into a control limit design. So if the client, it may get into those areas we talked about where we don't want to overheat something, or we don't want to overheat the pipe. So we want to make sure that we have some kind of control limit design in that case. I guess that's what they're looking for.
Okay. The next question, and this is would probably be addressed through a more in-depth dive into self-regulating cable, but a simple comment of selecting breaker size for SR cable.
Yeah, so typically we depend upon Chromatrace to do that for us, right? If you go in and put your all of your data in there, the circuit length, the pipe size, the insulation types and thicknesses, then the software is going to pick the appropriate breaker. It's not going to let you pick undersized a breaker for that application. So, and it's only going to let you choose a breaker that's at 80% of its rating. So you don't want to manually do that. You've got to run the calculations to be able to figure out what your inrush is and what your steady state current is. So we depend upon our Chromatrace software to pick those breakers for us.
And that's available to everyone. We had the training last week on that as well. And there's charts too. There's literature on the website.
Yeah, I was going to mention that too. If you want to, you can go to a chart.
Okay, yeah, we're getting a lot of questions here, Chad. Please define ground fault protection and how it relates to heat tracing.
So the National Electric Code, I believe in 1987, required a change in ground fault protection, and that each individual circuit has to have ground fault protection now. And so you either have to provide ground fault protection through the use of a ground fault breaker, or you have to provide it in your controller. It's basically protecting, you know, just like any other circuit. If we detect a ground fault, it's going to trip the breaker and not allow the cable to sit there and arc and spark and start a fire. So those are the two ways that that's what ground fault's going to do, and those are the two ways that you can accomplish it. But it is required by code, and if you don't have it on your current system, I would advise that you install ground fault breakers.
Okay, great. This next question actually, I'm going to combine two. The single point or 2-point heat trace controllers are limited to 100 to 277 volt. Do we have any controllers rated for 600 volt, 30 amp? Any 2-point controllers? No, I'm going to say
no.
No, we don't. Yeah, you have to go into the larger panel size just to get the. None of our cables rated that high or self-regulating cables, so they have to break it down or just distribute it in the panel.
You know, another point there too, Derek, is that a lot of end users do not like their maintenance or electricians going out and working on 480 or 600 volts, and they don't like having that kind of voltage mounted up on piping and vessels. So that's hidden up underneath insulation. So they try to avoid those where possible. I mean, you may see 480 volt on some really long transfer lines where there's not a lot of activity or maintenance, but in a typical 1 or 2 point application, a lot of people like to stay away from those kind of voltages.
Okay. Next question is do we offer a wireless RTD capability? And in that case, I can take that one. Yes, we do.
Yep.
Yes, that's certainly available.
And Derek, one other thing about that, if the client has already installed that wireless HART system, we can add our wireless RTDs relatively easy if they do have it currently installed. So, you know, in the case if you have let's just say you're out on the dock somewhere and you need to add additional RTD that's way out somewheres, the wireless RTD may be a great option, or in a remote area of a tank farm or something. If the wireless system's there, it's a good way to add a wireless RTD.
Okay. This is another further comment on RTD locations. Something we've experienced relates to increased heat loss from wind exposure. So what's your thoughts on multiple RTDs functioning a circuit where there could be both sun shade differences as well as wind exposure? I guess that would be using multiple sensors to turn on your heat trace system?
I have, if the system is properly, I don't know what you mean by wind exposure, because if the RTD is mounted underneath the insulation, it shouldn't be exposed to wind. If you are having some issues and you'd like to install a secondary RTD, you could do that down the line. It's not, you can do it. It's not something that's, it's not a standard practice, but I have seen in some instances where if you're having trouble with a line, maybe a second RTD gives you a different option. You can do the average of the two. You can control off the lowest. So you can do that if you're having an issue maintaining a certain line. But if it's installed properly and it's heat trace and it's insulated properly, you really shouldn't be having that issue. If you're having wind issues, maybe you need to design it for a different, maybe you need to go back and look at redo your design.
Well, and also the sensor mapping too. You can also adjust where you're pulling your sensor from. Let's see, the next question. We're getting quite a few here. Again, back to RTDs in the sun and shade. There's actually several questions about that coming through now. If an RTD is in the sun and pipes are in the shade, would it be possible for the heat trace not to come on when the pipe is colder? And I would certainly say yes. I think that would be something to consider. But what is the best place to put the RTD in relation to sun and shade? And also, if you're doing line sensing, pipe flow, right? Would you put it in the bottom of the pipe? Would you put it in the shade? I guess that it's all kind of all about where to locate your RTD again.
Yeah, so in the case of roof protection, we typically like to have that RTD, ambient RTD, out in the open and not in the shade. As far as line sensing, that's going to depend upon your flow, where the flow is. I would highly recommend that you keep it away from valves, move it away from large valves or large heat sinks, or a place where you have an insulation blanket, because you may get some effect on that RTD if you mount it too close to a valve or too close to a blanket. So, but in the case of line sensing, it's going to depend upon the flow. And so typically you do want that on a horizontal pipe. Try to put that on a horizontal pipe, horizontal run, and not a vertical run, or you don't want to put it at the top of a vertical run. If you do have a really high vertical run, you might want to pack some insulation in there to keep the heat from rising up that vertical riser and then affecting your RTD if you put it at the top. I've seen that happen numerous times. So hope that answers your question.
Yeah, so essentially we want to put it in the most critical area. So in the case of freeze protection and ambient sensing, to answer several of the questions through there, the shade might be the optimal place to put the RTD. In the case of flow, where's your critical spots, to maintain that temperature? And that's just, simple review. Skipping back real quick, Chad, on the limiting question. I got a further clarification, a place where the limiting for self-regulating cable would be very important in the case of, say, a safety shower. Some EH&S type application, you can't go over a certain temperature, then the limiting would be required, actually, in some cases.
Right. So I guess they're referring to upper temperature limits. Yeah, that's correct.
I got further clarification. Sorry about that.
Yeah, so in the case of that, you're correct. We don't want to overheat the water that's going to a safety shower. So you could do one or two things. You could put an RTD, you could have your RTD turn off at an upper temperature limit, or you could size your cable such that, based upon the pipe and the insulation type and thickness, that even in a runaway condition, you're still at a safe temperature to turn that safety shower on. So there's a couple of things that you can do there. A lot of times, if you want to talk about that, like for 50% caustic, we don't want to get above about 100, and most people maintain this stuff around 78 or 80. When you start getting above 100 and 110, 112, it starts to become hyperactive. So in that case, you need something to shut off at a higher temperature limit, or you also can design it such that if you do have a runaway, your cable's not going to overheat that pipe.
Okay, very good. Then next question is, do we have any cables that are rated for 480? Self-regulating, no, but are some developments. But our MI cable, of course, is up to 600. Would you agree, Chad?
Yep, you can get the MI cable. The MI cable is the only cable that would get up into those voltages.
Okay, fair enough. Back to the wireless RTDs, is there any distance and length from the controller, or probably have to go through the I&M on that?
Yeah, I'm not, that would be something we may have to address afterwards. I'm not sure what the distances are on those. We do have repeaters that you can install if you are at longer distances. So we know have those, or if you don't have a direct line of sight with RTD with the controller, we'll have to put in repeaters, but there are repeaters that you can use.
Okay. Okay. Yeah. Then I got further comments about the control limiting designs are generally used to reduce sheath temperatures in MI cables as well. So a lot of comments about that, which is really good.
Yes, the control limit design limits the sheath temperature of the MI cable. That's something else that you're trying to reduce.
Okay, excellent. I think we got to all of them. Some more comments about putting the RTD in the shade, and of course, giving back to obviously mount your RTD and your sensor in the critical area. If the temperatures in the shade are the concern, then I would assume mount in the shade. If pipe temperature is a concern, mount in the right place of the pipe, correct?
Yes. Yes.
Let's see, we got a few others here. I did get some clarification on the distance. It's 200 feet max for our standard RTDs. I'm not sure if that's just for the wireless. That doesn't make sense. Here's a question for you, Chad. What's the difference with stabilized and controlled design? Still with us?
Do what? Yeah, I'm still there. I don't know. I'd have to go back and look at that. I'm not sure what they're asking. I have to go back and take a look at that. I'm not sure.
Yeah, whoever asked us that question, please. You've got our email right there. Why don't you email that offline, and we'll discuss that with you further, because I'm not sure we maybe understand that one. The question. Appreciate that. Okay, let me take another look here. We got let's see, we got okay, we got that. Some of them are just comments coming in now. Here's a good one. Are we planning on having a webinar about frost protection on ground applications? I would say yes, absolutely. And actually, on our commercial division, we already did one. We'll look about doing that. I'm actually going to make a note about that right now. And possibly just we already have an internal one that I might be able to just provide to everyone, but it would be nice to have a presentation for everyone here shortly, especially going in the cold weather season, right? Good comment there. Other than that, Chad, do you have any parting thoughts? I know we're getting here towards the end of the hour.
No, I would say that we're getting close to winter season, so the sooner you can troubleshoot your heat tracing and get it moving, and if you need our assistance, let us know. We'd be more than happy to help you through our service department. So get ready. We're like the cold weather's coming.
No, I certainly appreciate that. And that's also the purpose of why we started doing these. If you got any thoughts, suggestions, things you want to know more about, please contact me, and we will start getting more of these put together and available to everyone. Topics and ideas and thoughts. So, Chad, I appreciate it. Good job. And unless okay. There's a lot of questions here. I'm trying to make sure I didn't miss anything.
Thanks for everyone's attendance. We surely appreciate it.
Yeah, excellent. And yeah, I got some clarity on the stabilized design versus the limited design, but we'll get back to that individual afterwards. So good. Well, thank you all, and thank you, Chad. Appreciate everything. And I'll let everyone. Thanks for attending. We'll have more here shortly.